When facing a sudden drop in profitability or a market shift, the standard instinct is to gather every available spreadsheet and data point, hoping that if you look long enough, the right patterns will emerge. In high-stakes environments, this data-first approach typically leads to analysis paralysis. The sheer volume of information obscures the path forward rather than illuminating it. The McKinsey Problem Solving Framework offers a structured sequence to bypass this analytical gridlock. This method is built specifically for ambiguous, unstructured problems, where the root issue is completely unknown at the start. It frames analysis to enable executive-level decision-making, ensuring the team stays focused on producing an answer rather than conducting an open-ended academic study. Effective strategic problem-solving is problem-driven. You must build a logical structure for the question before you ever begin gathering data. The McKinsey methodology is defined by its highly structured, hypothesis-driven approach to complex business variables. Hypothesis-driven analysis acts as an operational constraint. By stating a probable answer early, analysts avoid mining data blindly and focus strictly on what is required to test their assumptions. To organize these assumptions, the framework uses a rule called MECE, mutually exclusive, collectively exhaustive. MECE ensures that every part of a problem is accounted for without any overlapping categories. Combining this MECE structure with the 80-20 rule, the idea that 80% of effects come from 20% of causes, forces the team to prioritize the critical drivers of value. These rules translate raw, messy information into fact-based, actionable insights for leadership. This 7-step process forms the architectural spine of the framework. It begins with defining the problem precisely as a decision-oriented question. Step 1 requires establishing a clear objective, while defining the explicit scope and operational constraints the solution must live within. In Step 2, you decompose that complex question into smaller, independent components. This issue tree demonstrates the mutually exclusive half of MECE. Splitting profitability into revenues and costs isolates variables so analysis never overlaps. It's collectively exhaustive because sub-branches, like new versus returning clients, account for 100% of the possibilities within those categories. A properly constructed MECE tree transforms an intimidating, ambiguous question into a finite checklist of verifiable math problems. Step 3 involves forming initial hypotheses based directly on the branches of the issue tree. You move from a broad list of ideas to a specific claim about what will drive the most impact. A hypothesis is an educated guess used to direct the analysis. It is a starting point for investigation, not a final conclusion. Step 4 is prioritizing these hypotheses using the 80-20 rule. Analyzing every branch of the tree equally is a strategic error. You must ruthlessly ignore low-impact areas to conserve analytical resources for the drivers that matter most. This hypothesis engine ensures analysts only pull the specific data required to prove or disprove the highest impact assumptions. In Step 5, you design targeted analyses, like variance analysis or KPI decomposition, to test the prioritized hypotheses. KPI decomposition involves breaking a high-level metric into its individual mathematical components to find the specific point of failure. Step 6 is the synthesis of those findings. A summary merely repeats facts, such as noting that transport costs rose 12%. A synthesis translates those facts into an answer for the business, explaining that the cost increase erodes 60% of the margin gain. Effective synthesis answers the question, what does this mean for the decision? This leads to Step 7, formulating the final recommendation and driving action. An executive-ready recommendation explicitly states operational trade-offs and the immediate next steps required for implementation. This 7-step process functions as a funnel, compressing infinite data possibilities down into a singular, risk-weighted business decision. These abstract principles apply directly to the scale of real-world supply chain operations. Complex challenges like global network redesigns or targeted cost-to-serve reduction programs are perfectly suited for this framework. The framework systematically diagnoses structural gaps in cross-functional processes like S&OP. S&OP, or Sales and Operations Planning, is an integrated process where leadership aligns demand, supply, and financial goals across the entire organization. Applying this logic shifts the management focus from reacting to daily bottlenecks towards strategically redesigning systemic value drivers. A common misconception is that MECE structuring creates unnecessary complexity. In practice, its actual purpose is to force absolute clarity. We can see its utility by comparing it to engineering tools like root cause analysis, or RCA, and DMICE. DMICE stands for Define, Measure, Analyze, Improve, and Control, a data-driven cycle used to optimize established processes. RCA is backward-looking, searching for a fault that has already occurred. The McKinsey framework is decision-forward, designed to navigate future unknowns. DMICE optimizes stable existing processes. The McKinsey framework defines completely new operational strategies. The 7-step framework functions as a flexible thinking system that adapts to the geometry of the problem. Structuring the question before looking at a spreadsheet provides the discipline needed to handle infinite amounts of data and drive actionable decisions.